Hello everyone, I'm Ajita Basar. Welcome to another episode of Automation Digest. I'm back again with another DSA problem. The problem is asked by many organizations in the interview, which is best time to buy and sell stocks. Today we will be taking the easy variant of the question. So let's jump into the question. As I mentioned, it is an easy question. What does the question say? We are given an array where prices I is the price of given stock on ith day, which means in the array, as we move towards right, our day increases. We want to maximize our profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. The buy and sell has to be done only once. If we do not achieve any profit, we have to return 0. The constraints are the length of the array is between 1 to 10 to the power 5. The prices can be between 0 to 10 to the power 4. Let's look into the example. We are given here 7, 1, 5, 3, 6, 4. If I buy the stock on day 2, which has the price 1, and sell it on day 5, I will have the maximum profit, which is 5. In the next example, it is a decreasing array, which means in the next days in future will always have prices lesser than the one that we would have purchased at. So the profit cannot be achieved in this example. So the output is 0. On the right hand side, we have the array of prices as input and we have to return integer as the profit. All right, let's understand how to do this solution. Let's say our array under consideration is the first example. Now we want two variables. One is the minimum price at which we can buy the stock and the maximum profit that we can achieve in the array. Now we start from index I equal to 0. At index I equal to 0, let's assume that this is the minimum amount at which we can buy the stock. So the minimum is now kept as 7 and the minimum profit that we can achieve at any given point is 0. So let's assign 0 to profit. Now our pointer moves to the next one. We find out that this is even smaller than the previous one. If it is smaller than the previous one, we replace the minimum with 1. The profit still remains as 0. Now we move to the next one. We see that this is not lesser than 1. Hence, profit is going to be achieved. So in this case, we subtract the value 5 minus 1 or 5 minus the minimum value to find out the profit. In this case, it becomes 4. Our minimum is not updated. The pointer now moves to the next one, 3. Again, this is greater than the minimum. The profit in this case is 3 minus 1, 2. But the profit that we have already achieved is 4. 2 is lesser than 4. So we do not consider 2. We move our pointer to the next element. Now, 6 is not lesser than 1, which means minimum remains as 1. The profit becomes 6 minus 1, which is 5, which is greater than 4. So the profit is now replaced by 5. Our pointer now moves to the last element, 4. It is not lesser than 1, so we will achieve a profit. The value is 3, which is again lesser than 5, so not considered. Our output finally is returned as 5. The time complexity that we would require is O of n because we are moving through the array from the beginning till the end. So what did we understand? The minimum has to be updated by the value when the value is lesser than already existing minimum, and profit has to be updated by the value when the profit is greater than the already existing profit. These are the two statements that we have to do in the code, and we are done. There is one edge case. If the array consists of only one value, which means we can buy the stock but cannot sell it, in that case as well, the profit becomes 0. Let's get rid of that edge case. Now, once we have got rid of the edge case, the next step is to take two variables. The minimum profit that can be achieved is 0. So let's assign profit to 0. At the beginning, we are assuming that the first element in the array is the minimum element. Now we need a loop for the traversal. I am considering I from 1 because 0 has already been taken care of. Let's say I assign a temp variable. We now require a temp variable to calculate the profit on every given day. Now we have to see if the profit that we have just calculated is greater than the already existing profit. If yes, the profit is going to be replaced by this one. So we have an inbuilt method of math, which is math.max. We can use that method to find out the maximum profit till day I. Also, we want to find out the minimum value till day I. And we are done. If I run this code, both the test case pass, and if I submit this, runtime, we were able to get the result in 2 milliseconds, which beats 93.44% of the users. And the memory utilization was at 61.08 MB, which actually beats 68.39% of the users. An easy solution with only 2 lines of code, which is normally asked in many of the interviews. We will do the next variants of the same question, a bit more tricky, in the upcoming sessions. Till then, happy coding. Do not forget to like, subscribe, and share.